Hello, ladies and gentlemen. Welcome to our very first series in biostatistics using R. R is an open source statistical package that can be downloaded and used for free. For you to get R, you will need to visit this very website, which is rproject.org. So when you come here, you will need to look for download right here. It says download. When you click on that, you'll see a list of countries. So you will need to pick your country and download from there. Once downloaded, an icon is going to be saved on your desktop, and anytime you want to use R, you need to go there and click and start using R. Okay, so once you open R, this is what you are going to see. This is the interface where you're going to perform your analysis. Okay, so in this series, we are going to be using two main types of data sets. One is the data set that is come with R, and of course the data sets that we are going to import, especially the Excel data sets. So for today and a few subsequent editions, we'll be using the data sets that come with R. Okay, so before I start to work, I want to erase or remove these words that shows the version. You can see that I'm using the version 3.53. This I think is old, so you will need to go and download the latest version on that website. Okay, so to erase and remove all these, I'm going to go to edit and I am going to clear console. So you can see now I have space to work with. So today we are going to just show you the basics, some of the things that we do when we import data. For instance, we want to explore the data, find out the number of columns, the number of rows. We can do the summary statistics for some of the columns or all the columns and so on. Okay, so because we are going to be using data sets from R, I am going to access those data sets by just doing library data sets. So this is the only way you can start to use the data sets that come with R. Okay, so when I enter, you can see there's no problem, which means that I'm ready to use those data sets. And I'm particularly interested in the data set called Iris. Okay, so let's take a look at that particular data set Iris. So I'm going to type head Iris. So head means that I'm just selecting few rows and columns. Okay, you can see here, because I don't want to see everything, I have 6 rows and of course 5 columns. We'll have numeric variables, 4 of them, 1, 2, 3, 4, and of course the last column is a nominal variable, a categorical variable called species. Okay, what do I want to do with this? I just want to take a look, explore and see how some things, what this data set is going to tell me. Okay, so the first thing I want to do is to, let me say I want to find the number of rows in this particular data set, because it's not showing me all the rows. So I'm going to do nrow Iris. Okay, so this tells me that this particular data set has 150 rows. Let's do the same thing for columns. Ncol Iris. Okay, so it has so these are all the columns or variables: cpo.length, cpo.width, p2.length, and so on. So 4 are numeric, and the last one is categorical. Okay, so the next thing I want to do is to find the dimension. Now the dimension is just going to give me all the rows and all the columns without doing that individually. So I'm going to do dim Iris. So you can see it tells me the number of rows 150 and the number of columns are 5. Okay, so what else can I do with this Iris data set? I can go ahead and do summary Iris, summary statistics, something like that. So when I do this, this is what I get. Now you can see that for numeric variables, it computes the 5-number summary plus the mean. Okay, so for cpo.length, for instance, the minimum is 4.3, the first quartile is 5.1, the median is 5.8, the mean is 5.843, the third quartile is 6.4, and the maximum is 7.9. And it does this for all other numeric variables. Okay, now for the last variable, which is categorical or nominal, it gives us the frequencies of each of the levels of our species. So Setosa has 50, versicolor 50, virginica 50. Okay, now what if I don't want all these summary statistics for all the variables? I can just pick. For instance, if I want to do the mean for the very first variable length, okay, so let me do that to see if I can get the same thing, 5.843. So I'm going to do mean, and I am going to do parentheses iris, that's the data set, iris. Then to refer to the variable that I need, I am going to do a $sign pito, that's sipo dot length, sipo dot length. Now make sure that everything is correct. This is very case sensitive, so if you use a small case instead of uppercase, it's going to throw an error. Okay, so there's no error, so the mean is 5.8433. You can see right here is the same thing, the mean of sipo dot length. Okay, now you cannot do the mean for the nominal variables. Okay, so you can only do that for the numeric variables. Now, one other thing I want to show you before we go for today is the plots. I can decide to do a kind of numeric plots for one of the variables. So I can do plot. Let me do plot for sipo width. So I'm going to do iris $ sipo dot width, sipo width. Okay, so if I plot that, this is what I get. Okay, this wouldn't make much of a sense because this is a scatter plot. I would like to do a scatter plot comparing the two numeric variables or two numeric variables. Okay, so that's not what I want to show now. This is just showing you how you can do plots. Okay, so we're going to look into scatter plots and all other complex plots later. Okay, so I want to be able to see both the the two panels. So I'm going to do tile vertically, so you can see that I see my graph and where I do my function. So if I click on this this place where I do write my programs, I am going to go back to Windows and do tile vertically. So I want it to be on my left and I want the graphs to be on my right. Okay, so what else can we show? If I want to plot a categorical variable, and the only categorical variable here is species, so I'm going to do the same thing. I'm just going to go up and I am going to just change sipo.length to species. Okay, when I plot that, what do I see? You can see that now we have a categorical or qualitative graph. These are bar charts showing us the frequency for each of the variables or levels of species. So we have Setosa 50, versicolor 50, and virginica 50. Okay, so that's the much we can show for today. When we come next time, we'll start to do a slightly more complex analysis using R. Okay, we're going to show you how to make other plots and of course perform other statistical analysis. Okay, thank you so much, and see you next time. Bye bye.